Number 16, find the indicated values or value. We've got volume. You need to find the volume, which means how many cubes fit. How many cubes are in this drawing? And remember, there's some in the back, so you got to make sure you get the ones underneath, the ones you can't see. But how many cubes are in this picture here? Number 17, if possible, draw or answer. If not possible, explain. So we need to talk about this. Is there a triangle with the sides measuring 1 inch? So let me just say this is 1 inch, 3/4 of an inch, and 1/2 of an inch. So that's probably not a good drawing yet, like at all. So 3/4 and 1/2. This would be my 3/4 and 1/2 of an inch. Is this possible? Is this possible? We draw our answer. Is it unique is the question here. So let's think just for a second. Is this triangle possible? Let me show you what it might look like if it's not possible. Because there are triangles that are impossible to make. Let's say I have one here that's like 5 inches, and then I have one side here that's 2 inches, and another one here that's 2 inches. Now notice these will never touch each other. If we bend them down, we're still going to have an inch gap here, and these can never be a triangle, right? So this side plus this side have to be more than this side, okay? So let's see what 3/4 plus 1/2 is. 3/4 plus 1/2, because this is our longest side. It's an inch. These are both less than an inch. 3/4 plus 1/2, we need to make this common denominator of fourths. So it'll be 3/4 plus, how many fourths? It's going to be 2/4. That'll be 1/2. So this is 5/4, which is 1 1/4. It is longer than 1 inch. So we're fine. We're set. So that's all good. So this is a possible triangle. We've drawn it. And is it unique? So that would mean if this is the actual measurements, is this the only way we could have drawn this? Now, if rotating it doesn't matter. Rotating doesn't matter at all. But what if I said, like for a different triangle, let me get another color so I'm not super confusing. Another triangle I might say is 60 degrees by 60 degrees by 60 degrees. So all the angles here are all 60 degrees. But couldn't I then say, well, actually, that's not that triangle, it's this triangle? Because that's also 60 degrees, that's also 60 degrees. So we see that this one can have all 60-degree angles, but we could also argue, no, that's this triangle that has all 60-degree angles. But if we're talking about all the sides, if I measure and I give you the exact measurement of all the sides of the triangle, well, unfortunately, that's going to be the only unique version of this triangle. If I give you all 3 side lengths, you can't stretch this out or bend it or move it or anything. You could flip it upside down or rotate it around in a circle, but that's still the exact same triangle, just moved around. So this is a unique triangle. Give me this drawing of that triangle. Number 18, is the sample valid? And explain. A researcher surveyed a band class about the value of music classes in school. So when I say valid, I'm thinking, is it fair? Is this a fair question? If I wanted to find out if music class was important, and I only asked kids that were in band, would that be fair? Or should I maybe ask other classes? Should I ask everybody in the school? Is this a valid sample? Yes or no, and tell me why. Is it fair if I only ask the band class? Number 19, calculate the probability of the event. So probability is going to be a fraction. It's going to be a part in our whole. So the part, Cher has 13 pencils and 2 pens. We want to know what are the probability of her using a pen. So she's going to reach in her purse and grab one. She has a total of how many things? Well, we have 15 items. She has 2 pens, so there's the probability. 2 out of 15. There's a 2 out of 15 chance So 2 out of 15, we could write that as a decimal or a percent. You'd have to go 2 divided by 15. You get 0.13 repeated, or also 13% if we just round it. Is this likely? Is it not very likely? Is it extremely likely? How likely is it that this happens? Last one, number 20. We have a path that's 20 feet long and 3 feet wide. So let's looks like this. It's 20 feet and 3 feet. How many cubic feet of gravel will be needed to cover the path with 3 inches? So now I'm going to make this give it a little depth here too, by 3 inches of gravel. So this will be a rectangular prism, okay? And the volume of a rectangular prism is length times width times height. But notice we have measurements in inches and in feet. We're going to need to do a little bit of work on this one. And I'm not going to do all of the work. We're going to need to convert this to inches. So 20 feet, well, let's see, 1 foot is 12 inches. So we need to do this 20 feet times 12, and that'll give us how many inches are in 20 feet. You got to do that with this 3 as well. 3 feet times 12. So this one will be 36 inches. Whatever 20 times 12 will go right here. And then you multiply 3 times 36 times that big one here. And you'll get the total. How many cubic feet? Oh man, they wanted in cubic feet. Do it in cubic inches. That'll be fine for this one. I don't have enough room. How many cubic inches of gravel will be needed? So it'll be this multiplied number, this large